All right, guys. So let us do what we can do in the short time that we have, probably about 45 minutes. Okay, so look at number 1. By the way, I like to jump around questions, right? I don't like to do from 1, 2, 3, and 4. That's what I like to do.
Sir, answer is 1 minus 4. Yeah.
Yeah, it will be 1 minus what? 4i, not true?
Yes, sir.
Yeah, because remember this would have been a complex number is written like this, x, or is 1. This is 1 we're writing a complex number. All right, so this would have been the real part, and this section would have been the imaginary part. All right, pretty straightforward. All right. Let's look at number 2.
A, sir.
Yes, it would have been A, because do you remember the?
Sir, we are adding log.
Hold on. Yeah, when hold on. Right, there's a rule that says when you have, say, log AB. Log AB is what? Log A plus log B, correct? Whenever a product, you basically add. So this would have been well, what to do? You take logs of everything. So it'd be log T. Welcome everybody, Kiandra and Jamelia. You guys are here. You ladies are hearing me?
Yes, sir.
So it will be log A plus log X to the N. All right, and then there's this other rule in logs. When you have a power, you just bring it down. So the second part it becomes N log X. Follow? We good?
Yes, sir.
All right. Let's go to number 3. Any ideas?
Sir, the above equation is fx equal x squared. They go put -2 in it and equal it to 8 to find
Very
8.
good. Right. That's basically what you're gonna do. So where x is, replace x with -2 and equate it to 8. All right. So you have something like this. Can you compute that for me, please? Or find A.
Sir, -2.
-2. Well, that's 4. That's 6. So that's 10 plus A equal 8. Subtract 10 from both sides. We get 8. Subtract 10. Yes, you're correct, Patisa. It's actually -2. Everybody follow? Dana, you following?
Yes, sir.
All right. Jamila, Miss Gordon? All right. Can I clear this? Are you writing? Clear?
Yes, sir. I can clear it.
All
It
right.
cannot take a time to open the mic because my is my laptop.
Oh. All right. No problem. All right, let's go on to number 4. So basically, this is an equation. So you treat it like a what? A regular equation. It's just that sometimes these inequality signs, they have little small rules, right? So I mean, how would you solve this? What would you do? What are some of the steps would you do to solve this? Let me rewrite it up here. So
So you're gonna group like terms.
right, you're gonna group like terms, right? So where do you want to put x's, on the left or on the right?
So you're gonna keep them on the left.
You want to put x's on the left?
Yes, sir.
All right. Okay. So if you want to put all the x's on the left and all the numbers on the right, we need to subtract 4x on the right. So if I subtract 4x on the right, I have to subtract 4x on the left. So this is 4x minus 4x plus 1, and you know this will go away. 4x from 1x is negative what? 3x. Subtract 3 less than 1. So I need this negative 3. I need this term here on the right hand side. So what am I going to do to get rid of the negative 3 on the left? So you can go on the right hand side.
So you're gonna add 3.
Right, I'm going to have to add 3 to the left and 3 to the right. And as you know, this will go away, leaving behind negative 3x less than 4. And then now, what would I do to get rid of, to
You're
find
gonna
x?
divide by 3, both sides.
Divide both sides, correct, by negative 3. And x, there's going to be a change of sign, not true? Right, so anytime you divide by negative, the sign changes. Okay?
Yes, sir.
Right, wonderful. Any questions? Keandra?
But sir, if we divide by a negative, wouldn't it number 4 be A because there was a negative sign?
If you divide by, no, but remember the 4 was positive, not true?
Yes, sir.
Right, so if the 4 was negative, then you'll say 2 negative will cancel out to give you no, but why would we? Well, it wouldn't be A because 1, there's no negative at the 4, and you know it wouldn't cancel out. And then no, the sign would have to change. Follow? When you
Yes,
divide,
sir.
when you divide by negative in an inequality, the sign changes, all right? And here's another way in which the sign changes. If I have something like,
Sorry, sorry, sorry. My mistake.
that again?
I saw my mistake.
Oh,
Based on what you said, I saw what I assumed wrong.
okay. All right, let me show another case where the sign changes. For example, suppose you have 2 less than x and you spin it around. If you spin this around, it has to be what? The sign has to change to. Okay, so that's another scenario where the sign changes. All right, can I move on?
Yes, sir.
All right, so I came across this very interesting question. All right, and it's number 5. It's kind of a long question, so I have to zoom out a little bit. Hope you can see. Can you all see?
Yes, sir.
All right, what are your thoughts about this question? What comes to your mind?
Differentiation, sir.
No, you know. No, you know, Otisa. Let me tell you, it's in the first part of the exam, Otisa. You wouldn't get any differentiation. Like in section, where is the instructions? It has, all right, the question is 45. You have 45 questions, and I have 15 questions from module 1, and 15 from module 2 stats, and 15, the last 15 from calculus. So you wouldn't find a differentiation question in the first 15 questions. All right. Basically, you know, this is actually quadratic theory. All right. So what happened is that how do we well, first of all, if you look at the expression, right, it's a quadratic expression, correct? Look at it. It is ax squared plus bx plus c. Look at it. You all see that?
Yes, sir.
So you have a, b, and c. So it is a quadratic expression. Now, whenever you draw a quadratic expression on a graph, you always get a curve. Either it's a maximum curve or a what? A minimum curve. All right. I don't know if I ever, well, you know, if your grade 11 maths teacher would have taught you this, that when a is positive, we get a minimum curve. And when a is negative, we get a what? A maximum curve. All right. Follow?
Yes, sir.
So a maximum curve is like a frown. A minimum curve is like a smile. So let me ask a question. Is A positive or negative in this equation here?
Positive, negative, sir.
A is negative. Because remember saying, no, A is actually -1. All right. So therefore, this curve is a what? A maximum curve. That means, would you agree with me that B and D is out? Look at B and look at D. They'll be out, don't you?
Yes, sir.
So therefore, it has to be either A or C. All right. But here the trick, you know. If you notice, all right, let me just share something with you. If you have a quadratic curve, right, where the curve cuts the x-axis, they are called the solution of the equation, or the solution of the curve, or the roots of the equation. Or you're basically solving the what? You're solving the quadratic. All right. So here we're going to know. Would you agree with me that if you look closely at A and at C, they cross x-axis differently, not true? In terms of x-axis or x values, what's the difference between A
Sir, one is more positive and one is less positive.
and C? Yes. or to be more accurate, Otisa, what you could actually say is that in A, one value is positive and one value is what? Negative. All right. And in C, one value is what? More positive, as it correctly said. And the other value is what? Is negative. All right. But which one is which? How do we know that? And how do we work it out? Like, how do we know? What do we do? So guess what I want to know? We have to solve this thing, you know? Yeah, man. Yeah, man. So, oh, I need some space. So I'm going to go over here. So we have minus x squared minus 3x plus 10. All right. Now, is it because it crosses the x-axis? We're going to put it equal to 0. All right. Remember, this would have been the curve. And this would have been the x-axis. That's what it represents. Okay. So y equal to 0 is the x-axis. By the way, is that true? Is that true? On the x-axis, isn't y equal to 0?
Yes, sir.
Yeah, there are no x values on the sorry, there are no y values on the x-axis, so therefore y is equal to 0. All right. And we notice y is also equal to this. And because they meet, both of them are equal. Remember the thing about monkey, and you get monkey, something like that. So y is equal to this and y is equal to 0. So when you equate them, both of them are equal because they actually meet the x-axis. All right, so we're going to solve this. Now, to make life easy on us, what we're going to do is say, we're going to multiply everything by -1. You know why? Because normally we don't normally start at a quadratic with a negative. It's just awkward. So we're going to multiply everything by -1 to get rid of the -1. So therefore I end up with what? X squared. What's the other value?
Plus 3x minus 10.
Plus 3x minus 10 equals 0. Or negative and negative, you're positive, negative and positive, you're negative, right? And then now we're going to solve this. Now we can solve this two ways. We can either solve it using the factor method or we can use the quadratic formula. All right. Can I use a formula? Can I use a factor method to do this? I believe so, you know. So this is 1, right? So we're supposed to multiply a times c. Remember that? So what's a times c?
-10.
Right. So that's a times c is what? Negative what? 10. So we're going to multiply 2 and number them. And then now we're going to ask ourselves, we want two numbers. We're going to multiply, give us -10. I want to add those two numbers.
Yeah, it would be -2 plus 5.
We get 3. Right. So so Otisa says -2 and +5. So let's multiply them. When we multiply these two, do we get -10? True or false? True. -2 times 5 gives us -10. Let's add them now. Like -2 plus 5 actually gives us what? +3. So yes, you are indeed correct. All right. So the two numbers are -2 and +5. Then now we're going to delete the middle portion, right back the 1x squared. Drop in the two numbers that you get in no particular order. So it's -2x plus 5x. Subtract 10 equals 0. And then we factorize by grouping. All right, guys, let me just pause a second. Do you guys realize how much time we do this quadratic thing here? Like it comes up almost in almost every little topic, don't you? Quite a few topics, right?
Yes, sir.
No, but it just comes up. It comes up in factorization of cubic function. It comes up in complex numbers. It comes up in remainder theorem, and it comes up in this. It's amazing how this thing here is just so, it's all over the place. All right, so then now we factorize each bracket, so we see that x is common. So then therefore that must be x, subtract 2. All right, and then remember this, it has to have the same thing in the other bracket, don't you? Right, and then x minus 2 is common. So pull it out. What remains is x what? Plus 5. And then we split. So we have x minus 2 equal to 0. Obviously, that's going to be x equal to what? 2. So that's one value. You all see that? And then the other value is what? X plus 5 equal to 0, or x is equal to what? Negative 5.
So the answer is A.
Right, beautiful. So it must have been A, because that would be negative 5, and that's what? Positive 2. All right, so it couldn't be C, because if you get 2, it wouldn't match up, because 2 would have been somewhere like right here, and negative 5 will be out there. All right, so the answer there is A. Let me give you a little trick, a little secret. You see, when you got the numbers negative 2 and positive 5, you see, when if A is equal to 1, all right, you can actually look at these two values and get the answer. The sign will change. So A will be equal to what? Positive 2 and what? Negative 5. But it only works, you only do that when A is equal to 1. Get that? It's like it's a multiple choice, and you're not required to do all of this. You could just look at that. Follow?
Yes, sir.
All right. Come on, you following, boss? No,
Yes, sir.
you did both. All right, cool. All right. Can I move on?
Yes, sir.
All right. All right. We have about 30 more minutes. Guys, when I say 1 over here, I mean exactly 1 over here. All right. Somebody saying something to me?
I can't take some style,
Huh? You talking to me? Oh, it seems like somebody else. All right. Let's look at 8. All right. So, boy, let me tell you, is it if multiple choice, it's straightforward, My word. Let me illustrate what's happening. So we have a line segment, right? P and Q, all right? And those are the points, 1, 5, 7, negative 1. No, it's talking about the perpendicular what? Bisector. Bisector is in where? is at the midpoint, not true? So the perpendicular bisector is a line that cuts at right angles in the middle between P and Q. All right? And they want to know which of these points depend this line. All right? So this requires a lot of work. So the first thing you're going to have to do, one, is to find the gradient, which is M of PQ. So remember, this is X1, Y1, X2, Y2. Can somebody remind me of the formula of finding the gradient of a line segment? What remembers?
Yes, sir. Rise over run. So it's y2 minus y1 over
Right.
x1.
So you use a rise over run when you have a graph. All right. So there's no graph here. So this is -1, subtract 5, 7, subtract 1. All right, what is that, class?
-6/6.
-6/6, which is what? -1. So the gradient is what? -1. All right, are we clear on that? Then no, we need to find the midpoint of the line segment PQ. So midpoint, which is a capital M, what's the formula?
Square of
X1, that's the length here. And what? Y1, Y2 over 2. All right, so talk to me now. What's X1? 1
1 plus 7
plus 7. And then
5
what? 5
plus
plus
9.
plus -1, not true? Over 2. Correct?
Around is gonna be -2.
So this is going to be 4, right? 1 plus 7 is what? 8. 2 into 8 goes 4. A positive and negative give you a negative. 1 from 5 is what? 4. 2 into 4 is what? 2. Get that?
Yes, sir.
So the midpoint is 4 and 2. Are we clear? So the middle of the line is 4 and 2. Any questions? All right, then no. I told you there's a lot of things you have to do, right? After finding midpoint, what you're going to do is, remember, you know, it's a this is the line that we have. It's perpendicular to what? To PQ. All right. So what we need to do now is to find the gradient of line 2, which is a perpendicular bisector. Now, when two lines are perpendicular, right? What do we know about the gradients?
So when you add the gradient, then we get -1.
You're half right, not add. When you multiply the gradients of the two lines, that is the gradient of the first line PQ and the gradient of the other line, the perpendicular bisector, you get -1. Now, why are we doing this? Now, we're doing this to find the gradient of the perpendicular bisector because we don't know it. Why do we want the gradient of the perpendicular bisector? We want it because we want to find the equation of the perpendicular bisector to answer the question. So M1, the gradient for the first line is -1 multiplied by M2, and that is equal to -1. So what do I do now? I just divide everything by what? -1. So M2 is equal to what? Just 1. But it's not. So the gradient for this one, for M2, is just 1. The gradient for the first line is -1. What the following?
Yes, sir.
All right. No, after I do that, we need to find the equation of the perpendicular bisector. All right. Now we need two things to find an equation of a straight line. One, we need a point. All right. Do we have a point? The point would have been what? 4, 2, which is a midpoint. And do we have a gradient for line 2? Yes, it is equal to what? 1. All right. So then now we're going to use the formula y equals what? Mx plus c. All right. Now y is 2 because of that value of 2. M is equal to 1 multiplied by x. What is x? 4. All right. So when you input x, y, and m, the only thing we'll have back is what? C, which is called the y-intercept. So you have 2 equal 4 plus c. So 4 plus c is equal to 2. So c is equal to 2. Subtract 4, which is -2. All right. So equation of the line of the perpendicular bisector is, what to do? You write back the y. The m is 1, the x is x, and the c is what? -2. So ladies and gentlemen, this here we have here, so represents the equation of the perpendicular bisector. All right. Boy, what a wicked question. But then no, we're not done. We have one last thing to do. So much something I have to do to get to the answer. What we're going to do is say, to check, because really and truly, the equation of the this represents the equation of the perpendicular bisector. And we want to check if point A, if this point or one of those 4 points lie on that line. Now to do that, this is what we do. Let us try A. So A, what is x in A? 2. What is y? 4. So we use this thing here. Y is 4. So 4 is equal to 1 multiplied by x. What is x? 2. Subtract 2. You all see that? I just put x and y into this equation from A. What the following? So 1 times 2 is 2. 2 subtract 2 is what? 0. Is this a true statement? Is 4 equal to 0? No go so. So it's not equal to, not true. 4 is equal to 4, correct? So because they're not equal, then A cannot be what? Cannot be on the line. Do you follow?
Yes, sir.
So if it is not A, you tell me which one it is then.
Sir, is it B?
B as in boy or D as in donut?
B as in bat.
All right. Ano B, you know? It's not B here.
Yes, sir.
Yeah, because they're not equal. They have to be equal. What about C?
Yes, C. Sir, C is the
It is
answer.
C, that's true, because y is 2. And you have x. X is what? 4. So we have 1 times 4 is 4. 4 subtract 2 is actually 2. So is 2 equal to 2? Yes. So therefore, the point C lies on the line segment, the perpendicular bisector of the line segment PQ. That's a lot of work, you know, for one little question, not true?
Yes, sir.
All right, I think so. I think 1.5 hour can work with it. But let me tell you what. Some questions might go over the limit here. Yes, because for example, I mean, some questions just run off real fast. For example, if you notice, you know, number one, number 2 wasn't so bad. Number 3 wasn't so bad either. And number 4 wasn't so bad, but number 5 takes a lot of effort, I must admit. Right? And then yeah, number 8, oh god, it rough for number 8. I'm not gonna tell a lie. But the most important thing is that you know what to do now, not true? That's the most important thing, you know. You know what to do now. All right. All right. So all right, let's look at number 9. This is which of the following represents the equation of the line passing through the point 2 and 1. All right, so well, what I did a while ago was helpful of determining if a point passes through a line. Not true. We can actually test which one of them. Not true. All right. So the equation of a straight line is y equals mx plus c. All right. Now it says the gradient is what? Positive. It means that the line is falling to the right. All right. So it means and it also makes an angle of 45 degrees with the x-axis. So basically, you know, let us say this is our axis, and let us say we have a that's our line. So this is the y. That's our x. All right. And what they're saying, you see, between the x-axis and the line, it makes an angle of what? 45. All right. Now, to make an angle of 45 degrees on the x-axis would mean that the gradient would have to be equal to 1. All right. Do you guys remember I told you that gradient is actually the tangent of an angle, of a triangle? Anybody remember saying that? Gradient actually, sorry, the tangent that the angle that a line makes between the x-axis and the line, right? That angle is considered the gradient. All right. And to find that gradient, we use tangent rule. And that's how they came up with the definition of rise over run, because tangent is opposite of adjacent. And if you look at this thing here, this is the opposite, and this will be the adjacent. Opposite divided by adjacent, which is actually, so the O would have been actually the rise, the vertical rise, and the adjacent would have been the horizontal what? Run. All right. So basically what I'm trying to say is, see, the definition of what a gradient is came about from the whole tangent business. All right. Now, to get a tangent of 45, all right, it means because what is tan 45, class? Tan 45 is equal to 1, you know. So you know what they're saying? So in order for you to get 1, the rise has to be 1 and the run has to be what? 1. Because when you divide 1 by 1, what do you get? 1. So in other words, the gradient of the line is equal to 1. All right, so it could be any one of these, because if you notice, M represents what? The gradient. And all the gradients in these lines are all of them are all what? 1. All right. Okay. So we have the gradient out, and we have the 45 degrees thing out. So I guess what is left for us to do is to find out which of the line the points 2 and 1 lie on. Can you guys do that for me, please? We just did it a while ago. Replace y with 2 and x with 1, and see if the answer on the left hand side is equal to the answer on the right hand side. All right, tell you what, let me work out A for you. So we have 1 equal, I'm using this, y is 1 equal x. X is what? 2, subtract 3. So we have 1 equal -1. Is that true or is it false? Is that statement true or false?
False, sir.
False, because 1 equal 1. So it's not equal to. So A can't be the answer. So you determine which one is the answer.
Sir, the answer is C.
All right, let's try C. So we have y is equal to 2. And we have x. Sorry, y is equal to 1.
Exactly, sir. No, no, yeah, about
Come on, it's a little afternoon test. No? So y is equal to 1. All right, and x is equal to 2. So it's going to be 2 subtract 1. So 1 is, well, 2 subtract 1 is 1. Is 1 equal 1? Yes. So therefore, C is the answer. All right. It has to be C because number 1, the M is positive. See, it has a positive gradient. Because what they could have done, they could have put a negative right there, so beside the x, If a negative beside the x, it can't be that grade. That grade would have been what? Negative. So be careful. All right. All right. Let me see if I can squeeze. Let me see if I can find a simple question and work. All right, let's look at 11. It says which of the following statements are true if x minus 2 is a factor? No. If x minus 2 is a factor, is the first statement true?
Yes, sir. Along with the third one too.
Yes. Because remember, if x minus 2 is a factor, what they're saying, if you put 2, because you're gonna have x minus 2 equal to 0. So x is equal to 2. So what they're saying, if you put 2 into this, you have to get 0. Because that's the only way you can get a what? For it to be a factor. All right? As a matter of fact, 1 and 3 is basically saying what? The same thing. All right? It says f of x as a 0 remainder when divided by what? X minus 2. So 1 and 3 are correct. All right? Now, what is a root? All right? A root is actually the solution of this when it is equal to 0. In other words, where does this curve crosses the x-axis? So where the curve crosses the x-axis, those two values are called the roots. And what did one a while ago, don't you? With the 5 and -2. That's another name, for the solution between the curve and the x-axis, the roots of the equation. All right. Now what they're saying that x equal 2 is a root. All right. Now, let me backtrack a little bit before I answer it. Let me go back to the question that we did a while ago. Not seeing Chanel at all. I don't know where she is. All right. Do you remember this question what we did a while ago? We got x to be equal to what? 5?
Yes, sir. -2.
A -2, don't you? All right. No.
No, sir. -5 and 2.
Oh, sorry. -5. Okay. -5 and 2, right? Correct? Is that true?
Yes, sir. Because we got A as the answer.
Right, A for the answer. Right. No, let me ask a question. Is it these values here? So those two values, they are what we call the roots. the solution. So it means that if I put -5 into this formula and 2 into this formula, I must get 0. All right. Let's test it. Let's try 2. So you have subtract 2 square, subtract 3, 2 plus 10. So that's -4. Notice it is still negative, right? Plus 3 to 6 plus 10. All right. Hold on here. Something is not adding up. Oh, guess what? I'm using the wrong equation. Remember, we had changed equation. Equation is what? X squared plus 3x minus 10 equals 0. Remember that, guys? We have to multiply everything by -1, not true? So let's put 2 into this thing here, right? So 2 square plus 3 times 2 subtract 10. 2 squared is 4. 3, 2, 6. Subtract 10. What's 4 plus 6? 10. What's 10 from 10? 0. So we notice the roots. If you put back the roots back in the original thing, you'll always get what? 0. Do you get that? All right, let's go down now to this question here. So now, what this is saying, if you put 2 into this, if I put 2 into this thing here, if it is a root, I must get what? I must get 0, correct?
Yes, sir. So all of them is true. That means all of them is true.
Well, let's find out. But it answered the question, not true? Because in fact, if I put 2 into this, I do get 0, not true? So you're correct. So you don't have to work it out. All of them are what? True. Remember, we put 2 in the thing, and we got 0. So it is a root. All right. Okay. All right, guys. So